Hello and welcome back to Arise.Works, and this is episode 6 of our Getting Started with Shading and Rendering with Mantra workshop. In this section we will discover how to set up triplanar projections, and what different sliders do, set up a new default so we don't spend any more time than we need on creating new materials using triplanar projection, and finally using a material with diffuse, roughness, heights and normal materials we will create our alien rock. Fixing problems with gamma and any other problems that might arise along the way. So let's get started. Let's talk about triplanar projections. Now, as you can see in this scene, I have a sphere, I have the grid object just for the background, just to ground our stuff. Then I have the camera that we are looking through this camera right now. And as a final thing, I want to just add the environment light. I control, left click on the environment lights, and as per usual, just the light color of whites with a density of 1, but this time around I really want to have something more interesting, so I go to environment map, press this little button, and as you can see there is actually default HDRIs for the environment maps that are coming with Houdini installation, and I'll just double click or click accept on this long 2K texture. Now, if you are not seeing any pictures, you just can right click, press show images, and you will see different pictures here. Okay, I press accept, and as you can see, we have this cloudy setup going on. So let's see how it looks now. And I'll just, while it prepares the render, I'll go and create the principal shader. And as you have might guessed, we go and create triplanar projects. Okay. By the way, I'll just go to our objects, go to camera, and I don't really need to render everything that is around here. So I'll hold down the middle mouse button and scroll to the left. And focal length, I'll zoom in on our sphere. Okay, finally, we get the sphere, the principal shader 1, go back to materials, and all right, let's go to camera 1, update this, make this parts bigger to work with. Let's see what we got. Okay. So basically, this is our sphere with the default principal shader. Just to illustrate a bit better what is going on, I'll just wait a couple of seconds to finish the render. Okay, and now I hold down the Shift key, left mouse drag, just to isolate this part, and I'll make it the progressive enhancement. Now, finally, we go to our UV triplanar project. As you can see, there is a lot of things going on, a lot of tabs, buttons, and this looks a bit intimidating, right? So let's just figure out how this stuff works. So whenever you just create the UV triplanar project, it always comes with these defaults with max sharpness 0.25, tinting with colors, texture map that is not identified. So let's just go and identify the texture map. For this particular instance, I will again go to the default, Houdini Pictures, Textures, and I think, yeah, I want this metal, black and white. Why I'm choosing black and white for this particular one? Because I want to show you how the tinting with color works. So I don't want really to select on the y-axis, on the z-axis. And by the way, I'll just actually, let's go step by step. I will connect UV triplanar, and as you can see, y and z-axis are being colorized with their respective colors, as you can see. So z-axis goes blue, the y-axis, which are vertical positions, get the green tinting, and the x-axis, it gets the red tint with some sort of texture going on. This is the texture, as you can see. it is representative of what we have selected previously. So all working good, right? Now, if I scale it, the more scale you have, the more repetition will appear on our texture. So, okay. Max sharpness is how sharp the transition between the different texture projections are. Now, you're not seeing any textures on y-axis, so let's fix that. So let's do something different. Let's do these rocks. And for the z-axis, the final one, wood height, looks okay. It will serve just fine. So if I decrease the mask sharpness, the mask becomes more blurry. As you can see here, the transition is, well, it's taking a lot of degrees to transition from Z to X. And if I increase the sharpness, as the name suggests, it becomes really, really sharp. So if we increase the sharpness everywhere, as you will see in a moment, as you can see, it just projects, really just projects the texture from different angles. Now, if we are working with triplanar projections, chances are you want to project everything at the same scale, right? And let me just show you. If we go to and create another triplanar and press enter, as you can see, everything defaults to 111, everything is colored. And this will take a lot of time to set up, right? You don't want to create a new triplanar projections and spend like, I don't know, minute, 2, 3, whatever, to set up the triplanar projection. So let's override the defaults and let's create something that is usable. So first of all, I will disable the tints. I will get the scale, holding down Control and clicking middle mouse button. It will default to 1. Then mask sharpness will be, let's say, 0.3, 0.3, 0.3 in the z-axis, everywhere is 0.3. So instead of writing down each and every channel, as in like the mask sharpness, and going out there and fixing it on our own, we can just right-click here and copy parameter, and then we select this one, delete it, and then paste relative references. Same as here, paste relative references. So it says ch x mask sharp. So what it does is it actually copies whichever number is here to y and z. So if I make it like 0.5, as you can see, if I click here, you can see that indeed it copies. So whenever we move here, every single other axis inherits this number, which is really useful, saves a lot of time. Next up, I disable the tint with color because otherwise it would be really weird. It's just for visualization purposes, like the tinting with color, just so I can show you how it works on the sphere. And I disable tint with color here. Next up, I want to make the scale to be the same scale in the XYZ in every single axis. Otherwise, if you have the different scales, let's see what happens. It becomes skewed, it becomes irregular, it just looks strange, especially if you have some kind of intricate texture setup. So I would suggest having scale the same. So what we're going to do is, again, copy parameter and then paste relative references. As you can see, it says channel X scale 1, and it will copy everything that we input here. Let's check out how it works. So let's say I say 2 and press enter, and it becomes 2 as well. All right, so even faster way of copying that would be just right-click, copy parameter. Actually, you can say just Control-C, then you hit Tab, Control-V, and as you can see, everything inherits this one. Okay, we can do same here. Should work. Okay, let's see what we got. It says 2. If I make 3 here, let's see what we get. In the y-axis, we get 3. In the z-axis, we get 3. As you can see, just changing one number, we change everything. And finally, the texture map, again, in my experience, working with triplanars, texture map should be the same. So essentially, I will now delete this information because we don't need it just yet. Then we press copy parameter. Then we delete here, press paste, relative references. It says channel X position map. Again, delete here, paste relative references, and okay, let's see what we got. So I'll just stop for a second and press this cog and say save as permanent defaults. All right, let's see what we got. So I have creating another triplanar projection, and apparently we have the scale preset. If I change it, changes as well. We have the mask sharpness, which changes as well. And if I define the texture map, let's say these bricks, if we go to y-axis, it should be working. Let's see. Yep, that's a success. If we create the full material, as we can see, now we just have this sphere, but where do we actually would need something like triplanar projections? So I have created this thing, this blob. It's just a sphere that passed through a mountain. Then I did the VDB from polygons. Then I converted it back, subdivided a couple of times, and transformed. So it just looks like this. Yes, it's just a blob. Nothing interesting, and actually it doesn't even have any materials. Anyway, so if you're looking at this and thinking, well, this does not look like something I would like to be UVing and texturing by hand or whatever. We don't need UVs or anything else. Right now I just drag and drop the principal shader on this thing, and let's see what we got. Okay, I will reframe it. As you can see, everything works pretty well, but I don't really want this texture map be here. It just looks terrible. So I will delete this triplanar project, create another triplanar project, and I will insert, let's see, we go to the job, we go to the textures. Okay, and I have, give it a second, I have this rock texture that will be projecting as triplanar. So just for the showcasing the problem that can arise before you when you are just projecting textures using this, I will make the roughness 1, and don't worry, we will change the roughness after we're done with the fixing with the problem. So when I connect the triplanar to our base color, you will immediately see that it really gets the color that it should, but the color itself looks wrong. Here, it's obviously more saturated, it's darker, and it's just, this looks washed out, right? So the problem is that I have the PNG that has been exported into the 16-bit color format, and the triplanar project, when it inserts the texture map, it assumes that everything that has been 8 bits should be sRGB. and everything that 16 or more bit is linear. In my case, I actually have this 16-bit PNG that's supposed to be sRGB, but Mantra thinks it's linear. So it gets confused a little bit, okay? We can fix it rather easily, no problem. I just tap and start typing correction. As you can see, I just tapped C-O-R-R-E, and it was enough to get the color correction. I insert the color correction, and so to convert linear to sRGB, it takes gamma of 2.2 to get the correct values. And since actually Mantra confused it and did it in reverse, what we're going to do is essentially divide 1 by 2.2, and the result will be 0.454545. If we click here, yep, this is it, and the colors are now correct. There you go. We fixed that problem. All right, next up, I'll drag and drop holding down the Alt key. And by the way, you can minimize this. You can minimize this little window so it doesn't take so much space. So next up, I will add our roughness to the. Whoops. Where is it? Okay. Our roughness to the color. So basically, roughness is a black and white information, as you can see. Where is it? Here. It's a black and white information that is, again, being projected as a triplanar and colorizes things as we should. For now, I'll make the scale 1 here, scale 1 as well. Hold down the Alt key, create another copy. This one will be normals. And as we have discussed previously, to create those normals, you start typing normals, displace alone normal, color into the, whoops, not in the scale, hold down Y to create this connection into the amount, and displace normals into base normals. And there we go. But it will destroy our geometry. And you're like, well, as we can see, there is obviously shading problems because, as we already know again from the previous tutorials, that this scale is in default Houdini scale metering. So we have to make it really, really small. So it kind of actually represents how much it displaces the geometry. As you can see, naturally, the normals have started appearing and the whole geometry looks a lot better. So let me just showcase you. This is with normals. Okay, this is with normals. I'll press the snap. If I disconnect the normals, let's see what we got. This is without the normals. As you can see, no micro details, no interesting concavities and stuff like the usual rocks have. If we, as you can see, it's a drastic difference basically, right? Okay, I will just connect it back to our base normals. And finally, again, holding down the Alt key, drag and drop, displacement. Where is it? Okay, it's called height in our export. And the displacement, we press tab, start typing this displace, press enter, drop it here, connect the color to value, and the distance to displacement. Obviously, as we have discussed in the displacement tutorial, nothing will work unless you press the custom inputs enable here. And it will now destroy our geometry as well because the displacement of 1 is too much. Okay, but you know, it's working, so we just have to fix the scale. Now, as I have previously said, the offset is usually negative half value of the FX scale. So I'll just, again, right click, copy parameter, right click, paste relative references. and we will multiply negative 0.5 by this amount. So whenever I change the scale, as you will see, if let's say we have scale of 0.1, the offset will be just negative value divided by 2, which is really useful actually. Okay, as we can see, we really have the displacement, and it actually starts looking like more or less realistic rock. I would say 0.7 will be looking a bit better. All right. This is looking better. Now, as a final thing, I'll just, to fix a little bit the displacement shading problems that we apparently have, let's just render, give it a couple more seconds to render it to final version. So we have things to compare to. Okay, I'll press the snap button to stop the render. And where is it? Okay, our geometry already has the shading quality of 2 and flatness of 0.2 and full predicing. We actually can even increase a bit more. I don't know. These can help. Let's see the difference. And essentially, the best help that we can give our displacement, as previously discussed again, we can increase the subdivision amount. But, you know, with the new settings, it should be looking good. Okay. Let's subdivide it a little bit more. Let's see what we got. Depth will be 4. And maybe it's actually not a problem per se. Maybe it's just the sharpness of the mask. I'll say sharpness of the mask of the displacement. Let's make it 0.35 maybe. Let's see what we got. And press render once more. Should look perfect. I hope it will look perfect. Give it a second because, you know, displacement takes a lot of computational energy. All right. Yeah, this looks very good. This actually starts to look like a rock. And as you might have already mentioned, I have already mentioned, we did not use any UVs, no nothing. We just have a material and we just projected it from the X, Y, and Z axis. So this is as procedural as it gets because if we go back to our object and we transform our geometry somehow, let me just first save because I'm recording. I don't know, it might crash. I don't want the recording to crash. Triplanar. Okay. If we like make the geometry a little bit different, let's say offset of 2 here, we should create different looking bulger. All right. And now I press render again. It should be another alien looking rock, but with different topology, but it will retain our texture information and it will look pretty good. Hopefully. I actually think that for this, the dicing flatness of 0.1 is an overkill, but better safe than sorry, right? Okay, looking pretty good. So there you go. This is all you need to get to know to get started with the triplanar projection. And don't forget, like I said previously, if you do have a really weird color, let's say if I disconnect the color correction right now and I'll just pipe through and I snap here, you will see like the colors will be all wrong. So if you notice that your colors are really wrong, it means that Mantra got confused, and you have to correct the gamma into 0.454545. If you're lazy, you can just write here 1 divided by 2.2, and it will be just fine. Okay, so as you can see, it looks really pale, the contrast is no more, the colors are washed out, it's wrong. Anyway, there you go. This is Triplanar. Nothing really hard about it, or nothing is super problematic, except maybe for the usual problems with displacement and the normal map. Okay, so if your shading breaks, right? If like here we say scale of 0.7, the shading will break. It means that your scale in the normal projection is wrong. Okay, so there you go. Play with triplanars, play with all kinds of weird looking geometry. Remember, if you're like going for alien rocks and you have the textures and materials that look like an alien rock, anything will do. It will look just fine. Hopefully you find that useful, and see you in the next videos where we will discover how to shade and look depth more things. If you did find this useful, don't forget to press the like, and if you don't want to miss anything else from this workshop or anything else that we have in the making going forwards, don't forget to subscribe to the channel. If you have some ideas or just comments or want to share some of your experience rendering triplanar projections, who knows? Use the comment section below. I'll try to read everything and respond when needed. With that said, have a nice day and see you later.